So let's look at chemical equilibrium. Chemical equilibrium. So chemical equilibrium is defined as a reaction whereby backward reaction is cause of forward reaction. When the backward reaction is cause of forward reaction, their reaction is called equilibrium. That is, the rate of forward reaction is equal to the rate of what? Backward reaction. And the concentration of the reactant and the product remains the same. When the backward reaction is equal to forward reaction and the concentration of the reactant and product remains the same or remain constant in respect to time, that is what we call chemical equilibrium. So let's take an example of a balanced seesaw. A balanced seesaw. That is physical equilibrium. We have physical equilibrium and we have a chemical equilibrium. Let's look at example of a chemical equilibrium. If we have nitrogen, nitrogen is a gas, when nitrogen reacts with hydrogen to produce ammonia. NH3. Ammonia is a gas. Hydrogen is a gas, nitrogen is a gas. This is reversibility sign. This is what we call reversibility sign. Reversibility sign. These are our products. Nitrogen, these are our reactant. Nitrogen and hydrogen, they are our reactant. Why the product here is our ammonia? Ammonia is our product. Is the product form. So now we define chemical equilibrium whereby the rate of forward reaction is equal to the rate of what? Backward reaction in respect to time. That's what we call equilibrium. That chemical equilibrium is a state of reversible reaction whereby the rate of forward reaction is equal to what? The rate of what? Backward reaction in respect to time. Now, what happens in equilibrium? Equilibrium cannot just take place. There are some certain conditions whereby equilibrium can take place. Equilibrium can take place. Equilibrium only takes place in a closed system. Equilibrium only takes place in what we call closed system. Now, we have three major types of system. We have closed system, we have open system, and we have isolated what? System. So equilibrium can only take place in what? In a closed system. In this our topic, in respect to equilibrium, we are going to concentrate more on what? We will concentrate more on what we call chemical equilibrium. So now, before we proceed, what is a closed system? What is a closed system? If we're talking about EM, energy and mass, when there's no change in mass, in a closed system, the mass is what? There's no change in energy, but there can be a change in mass. In an isolated system, it's a system, open system, there can be change in energy and a change in what? Matter. You can change energy and what? A change in matter. So we have defined equilibrium as a reaction whereby the backward reaction and the forward reaction are equal. When the backward reaction and the forward reaction are equal, that is the rate of backward and forward reaction are equal in respect to what? Time. In respect to time, that's what we call equilibrium. And it happens in what? In a closed system. equilibrium can only take place in what? In a closed system. So now let's look at reversible reaction. What is a reversible reaction? A reversible reaction is one that can proceed both backward and forward. We have taken an example of reversible reaction in the world when nitrogen reacts with hydrogen to produce ammonia. That is a reversible reaction. Let's take an example of a reversible reaction. Let's look at when you decompose calcium hydroxide carbonate 4 to produce calcium tricarbonate 4 water carbon dioxide. In a closed system, carbon dioxide cannot escape. That's a closed system. We are going to look at conditions that must be met for a system to be at equilibrium. But before we proceed, we are going to look at some reaction. We are going to look at some reaction that occur under equilibrium, like the composition of calcium tricarbonate 4. It produces calcium oxide and what? Carbon dioxide. When calcium tricarbonate 4 is decomposed, it produces what? Calcium oxide and what? Carbon dioxide. Let's represent in this reaction, in this equation. Now, when calcium triisocarbonate 4 decomposes, when it decomposes, it produces what? It produces what? Calcium oxide and what? And water. It produces what? Calcium oxide and carbon dioxide. A carbon dioxide, this gas, solid. Now, this reaction is at equilibrium. Let's look at when hydrogen. Let's look at that example of a reaction at equilibrium. When hydrogen is a gas. When hydrogen reacts with what? Iodine to form hydrogen iodide. Let's balance our reaction. 2 hydrogen here, 2 hydrogen there, 2 iodine here, iodine here, 2 iodine here. Now let's look at when calcium tricarbonate 4 decomposes to produce calcium oxide and carbon dioxide. Now let's look at it properly. If the reaction is balanced, let's look at calcium here. Calcium here is what? One atom. Carbon here, 1. Carbon here, 1. Then let's proceed. Oxygen is what? Oxygen 3. Oxygen. Okay, now good. The reaction is also balanced because at any point in time, we'll make sure that our reaction are what? Balanced. At any point in time, let's take note of our reaction. Let's make it to be balanced. Now let's proceed. So just like what he said earlier, what we call dynamic nature of equilibrium. We are going to look at the dynamic nature of what? Equilibrium. We are going to look at dynamic nature of what? Of equilibrium. Dynamic nature of what? Of equilibrium. Dynamic nature of equilibrium. So now we can see at equilibrium, reaction does not stop. At equilibrium, during equilibrium, reaction does not stop. Reaction are always in a constant motion. That is, backward reaction is in continuous process to produce forward reaction, whereby forward reaction is in a continuous process of making what? Backward reaction. That's what we mean by that. So, number 1, reaction does not stop. 1. Reaction does not stop. Reaction does not stop. It means just like what you said earlier, the process at which A produces B and B produces C it has a constant motion. Let's look at something like this. When A react with B to react irreversible way to produce what C plus D, this is what we call, this is also a reversible reaction. Reversible what? This is what we call a reverse. This is also a reversible reaction. So don't forget, we are looking at dynamic nature of equilibrium. Number one, reaction does not stop. It means reaction are in constant motion of producing either product or reactant. Reaction, they are in constant process of either producing reactant or product. Now, number two, both backward and forward reaction are what? Continuous. They are continuous. Both forward and backward reaction are continuous. Both forward and backward reaction are continuous. So reactions occur at equal rates. Reactions, number three, reactions occurs at what? Equal rates. Reactions occur at equal rates. We are looking at dynamic nature of equilibrium. Reactions occur at equal rates. There is no net change in the concentration. There is no net change. There is no net change in the concentration. There is no net change in the concentration. There is no net change in the concentration. So we are looking at dynamic nature of equilibrium. Dynamic nature of equilibrium. We will be able to look at four major dynamic nature of equilibrium. So this factor are called dynamic nature, dynamic equilibrium. So now let's look at type of equilibrium. Let's proceed to look at type of what? Equilibrium. Let's look at types of equilibrium. Let's look at types of equilibrium. We're going to look at types of equilibrium. Let's look at physical equilibrium. Types of equilibrium. We are looking at types of equilibrium. Number one, let's look at physical equilibrium. Physical equilibrium. So under physical equilibrium, let's look at this together. We know a balance seesaw. We know of a balance seesaw, like in those days, like when children are playing at school, you see something like let's say this is a block of wood, and there's a pivot system here. Someone will be here. Let's assume you put a load of 50 kg. A load of 50 kg is acting under here, 50 what kg. Another load of 50 kg. The load can either be individuals, 50 kg. We can see In both, these are pivots. Of course, this is a machine. So now we can see that 50 is equal to 50, 50 kg is equal to 50 kg. It means that this block of wood will remain. That is, it will not tint either to left or either to right. It means the block of wood will remain. It will neither tint either to left or either to right. It won't. It will not tint either to left or to right. Why? Is because this force that is acting like this, we have clockwise and anti-clockwise. We have clockwise and anti-what? Clockwise. They are equal to each other. It means clockwise force is what? Is equal to what? Anti-clockwise force. That is why you can see that an object or a load that is here, and if they are of equal what? Mass, there will not be change. It will neither tint to your left or to your right. It will neither tint to clockwise direction or anti-clockwise. This is an example of what? Of a static equilibrium. And another type of equilibrium is like we have three persons. We have three persons on the other hand, and there are three persons and they are dragging a rope. If the weight of the one person that is equal to that of three persons, they will remain in the same position. They will remain in what? In the same position. That is what we call also static equilibrium. They are what? They are equilibrium. They are equilibrium. So now we are going to look at example of a static equilibrium. Example of what? Examples of physical equilibrium. Example of physical equilibrium. So we can see ice is equal to water. Ice is equal to what? Water. So if we have a cube of ice, leave it for some time, it will melt and change directly to water. Another example of static equilibrium is what? Or physical equilibrium is what? Dissolution. Dissolution of salt in water. Dissolution of what? Salt in water. Dissolution of salt in water. Saturated solution. Saturated what? Solution. Dissolution of salt in water, saturated solution is another example of what? Physical equilibrium. Now, let's proceed to chemical equilibrium. Let's proceed to what? Chemical equilibrium. Let's proceed to chemical equilibrium. Chemical equilibrium. Chemical equilibrium. So, chemical equilibrium occur when the backward reaction is equal to forward reaction and there is no observable change in the property of the system with respect to time. When the forward reaction is equal to backward reaction and there is no observable change in the property of the system with respect to time, That's what we call chemical equilibrium. When the backward reaction is caused of forward reaction and there is no observable change in the property of the system in respect to time, it's called equilibrium. When the backward reaction is caused of forward reaction and there is no observable change in the property of the system in respect to time, that's what we call chemical equilibrium. Now we are going to go in details and look at chemical equilibrium very well. Example of a chemical equilibrium: when sulfur 4 oxide when sulfur oxide react with oxygen, when sulfur oxide react with oxygen, when sulfur react with oxygen to give sulfur 6 oxide, so say gas. Let's balance our reaction before we proceed. Let's balance our reaction. Okay, let's balance our reaction. Now we can see sulfur is what? 1. Sulfur is 1. Sulfur is balanced. Both atom of sulfur in both reaction, in both reactant and product side are balanced. Don't forget these are reactant and these are our product. Now let's look at it. Sulfur is what? 1 here. Sulfur is 1 here. Now oxygen is what? 2. Oxygen is what? 3. Oxygen is not balanced. Now let's add 3. Oxygen is 6 here. 2 times 3 is 6. Oxygen is what? Now oxygen is 6 here. Now oxygen is what here? 6. Oxygen is what? 6. Because 2 times 3 is 6. Good. Now once you added the number, start again. Sulfur is what? Sulfur is 1 here. Sulfur is 2 here. So make sulfur to be what? 2. Let's start again. Sulfur is 2. Sulfur is 2. Now let's look at oxygen. 2 times 4. 2 times 2, 4. 4 plus this. We have, for oxygen, we have 4 here plus 6, which is 10. Which is 10. Which is 10. So the reaction is balanced right now. Our reaction is balanced because oxygen is 4 here. Oxygen is 6. Oxygen is 6 here. Sulfur is 2. Sulfur is what? 2 here. So reaction is balanced. Let's proceed. We are looking at chemical equilibrium right now, and we have looked at physical equilibrium. We are now looking at chemical equilibrium. So we have looked at our product. We have sulfur 4 oxide plus react with oxygen to produce what? Sulfur 6 oxide. Now, as time progresses, we are going to look at how to nomenclate. How do you know it is sulfur 4 or sulfur 6? How do you know? That is a topic for a different day. For another time, we are going to look at it together. We'll be able to, that's what we call inorganic nomenclature. That's what we call inorganic nomenclature. That is a topic we're going to treat next time. But before we proceed, let's look at our reaction very well. All the reactions, they are in one phase. They are in gaseous phase. Gas, gas, gas. Let's take note of that because we notice that one of these conditions for a reaction to be in equilibrium, at least they should be in gaseous state. Some of the products should be in what? Gaseous state. And there must be different number of mole. There must be different number of mole. We can see we have one plus, we have 2 here. We have 1 plus 2 plus 1 is 3. So we have this is our reactant, this is our product, right? So we have 3 mole here, 3 moles in what? In our reactant, and we have 2 mole in our product side. We have 2 mole in our product side. So we are going to look at condition that must be fulfilled before a reaction can occur in an equilibrium system. Now, number 1, reaction must be what? Reversible. So system must be number 1. Reaction must be what? Reversible. Reaction must be what? Reversible. Reaction must be reversible. Reaction must be reversible. Number 2, reaction must occur in what? Must occur in what? Closed system. Must occur in what? Closed system. Then number 3, temperature must remain what? Constant. Temperature must what? Remain constant. Temperature must remain constant. No addition. Concentration must be constant. Must be what? Constant. Concentration must be what? Constant. Concentration must be constant. Now let's look at law of mass action. Law of mass action. Law of what? Mass action. We are looking at law of what? Mass action. Law of mass action. Say at a constant temperature, the rate of reaction is proportional to the product of the active masses. That is what law of mass action says. It says at a constant temperature, the rate of reaction is proportional to the what? To the product of the active masses or concentration of reactants. So that is what law of mass action says. Now let's look at it. For example, when A plus B, when A combine with B to produce C plus D, in this reaction, let's put the subscript A. Let's put that subscript there. B, C, D. Now, for us to get the equilibrium constant, let's get the equilibrium constant. Equilibrium constant is denoted as K, which is equilibrium constant will now be CD, C plus D. Equilibrium constant, it will now be C plus D. Let's put our concentration sign. C, D. CD over what? Let bring your reactant A plus B, then A, B, AB, where this is concentration mole per dmq. This symbol is concentration in what? In mole per dmq. That is concentration in mole per dmq. So let's look at types of equilibrium constant. Let's proceed to types of what? Equilibrium constant. Types of equilibrium constant. So we have some type of equilibrium constant. Kc, we have number one is Kc. That is one type of equilibrium constant. We have Kp. We have Kp. That's another type. So this is Kc, say based on concentration mole per dmq. This is based on concentration in what? In mole per dm what? Q. This is based on concentration in mole per dmq. Kc is based on concentration in mole per dmq. Why Kc is based on partial pressure for gases? Why this one is based on what? Partial pressure for what? For gases. Based on partial pressure for gases. So from there, we can say Kp, we can get an expression for Kp, Kc guys, those are the expression. ROT change in what? So those are the two types of equilibrium constant. Those are the two types of equilibrium constant. Why R is what? Gas constant. R is our what? Gas constant. R is our gas constant. Why T is temperature in Kelvin. Temperature in what? In Kelvin. Why T is temperature in Kelvin. So change in mole of gaseous products. This is change what? Change in mole. That is change in mole. So let's look at characteristics of equilibrium. Let's look at characteristics of equilibrium. Equilibrium has some certain characteristics. That is what we are going to look at right away as an our second subheading. Let's look at characteristics of what? Of equilibrium. Characteristics of what? Of equilibrium constant. Characteristics of what? Of equilibrium Characteristics of what? Of equilibrium constant. Number one, it what? Depends only on what? On temperature. It depends only on what? Temperature. And number two, it is independent of what? It is independence of what? Of initial concentration. It is independent of what? Of initial concentration. It's independent of what? Of initial what? It is independent of what? Of initial concentration. So large case equals to product favored. Large equilibrium constant. Large equilibrium constant is equal to what? Product formation. Is large equilibrium constant is equal to what? Product formation. When your equilibrium constant is big, product are being what? Produced. When equilibrium constant is big, product is being what? Produced. Now let's look for the other characteristics. The fourth characteristic of equilibrium constant. Small what? Small equilibrium constant means reactant are what? Produced. Produced or what? Favored. Means reactants are produced or favored. Now, with that being said, I want us to proceed to what we call Le Techela's principle. Le Techela's principle. I want us to produce what we call Le Techela's principle. What is Le Techela's principle? Le Techela's principle. Le Techela. So, Le Techela's principle states that when a system is at equilibrium, Le Techela's principle says that when a system is at equilibrium and the system is not being altered, there's no change in concentration, pressure, and equilibrium. Say the system will adjust if there's a change in concentration, temperature, pressure. We are talking about three parameters: temperature, pressure, and we are talking about temperature, pressure. When the system is at equilibrium and there's a different and there's an alter, when there's change in temperature, pressure, and when there's a change in gases, say the system is going to adjust himself to another constrict, to another disturb. That is what Le Techela is talking about. When a system is at equilibrium, if a system is at equilibrium is disturbed, it shifts to oppose the change and restore the equilibrium. If a system is at equilibrium is disturbed, it shifts to another change to restore equilibrium. That is what Letéchiner's principle is talking about. If a system is at equilibrium and there is a change in concentration, pressure, those are the external constraints. Letéchiner's principle. Those are the external constraints. Let's look at Le Chatelier's principle. Le Chatelier principle states that when a system is at equilibrium, and there is a change or if an external constraint such as change in concentration, change in pressure, or change in what? Temperature. Is what is imposed on the system. The system will what? Adjust to unknown the what? External constraints. And of course, we know our external constraints. Our external constraints are change in concentration, change in pressure, and change in what? Pressure. Change in what? Temperature, change in pressure, and change in concentration. These are what? Our external what? Constraints that can affect the system at equilibrium. External what? Constraints that can affect the system at what? At equilibrium. So that is what Letéchiner's principle is all about. And this law is basically for what? Chemical equilibrium. The law is basically for what? Chemical equilibrium. Now let's look at factors that affect equilibrium. I want us to look at factors that affect what? Equilibrium. We're going to look at factors. So we have three major factors that affect equilibrium. Three major factors that affect equilibrium. We have, okay, let's look at factors that affect chemical what? Equilibrium. Number one, change in concentration. Change in what? Concentration. Number 2, change in what? Temperature. Number 3, change in what? In pressure. So these are our what we call external constraints. External what? Constraint. So what we defined earlier, which is the electrical spring we discussed earlier, when a system is at equilibrium and there's a change in concentration, pressure, when there's a change in concentration, temperature, or pressure, the system is going to adjust itself in such a way to annul the constraint. It's just like you are standing close to a waterfall, or let's say a train station, somebody, or let's say you are standing close to somewhere that is, close to a fire, somebody happens to give you a tint, a push like this, or somebody happens to push you, you will adjust yourself. It's natural. So that is what Letechiela's principle is telling us, that when a system is at equilibrium and any of the external constraints is imposed, like change in concentration, change in pressure, and change in temperature, the system will adjust itself in such a way to annul the external constraint, thereby restoring, going back to what? State of equilibrium. Thereby doing what? Going back to what? A state of equilibrium. That is what Letechiela's principle is telling us. That is what Letechiela's principle is sorry about. So we are going to look at we are still going to look at more explanation on what actually happened, what effect does change in temperature, pressure does, what does it happen, what happened to a system at equilibrium when any of these factors are changed. That is what we want to look at right away. So before we proceed, so far we have been able to look at 3 things that affect the system at equilibrium. We say it is temperature, change in temperature, change in pressure, and change in concentration. And we also confirm and we notice that those are the external constraints. Those are external constraints. Now, let's look at what happens when a system is at equilibrium. We are going to look at for concentration, change in concentration. Let's take an example of calcium hydrogen triisocarbonate 4. Calcium hydrogen triisocarbonate 4. When it decomposes, it's going to give us calcium triisocarbonate 4 plus what? Water plus what? Carbon dioxide. Gas, liquid, solid, aqueous. Now, when calcium hydrogen triisocarbonate 4, this is calcium hydrogen triisocarbonate what? 4. When it decomposes, this is our reversibility sign. This is our reversibility sign. This is our reversibility sign. When it decomposes, it produces calcium triisocarbonate 4, water, and what? Carbon dioxide. Now, this is an example of a system at equilibrium. Let's look at more example of a system at equilibrium. More example. Let's look at when hydrogen When nitrogen is a gas, react with hydrogen gas to give what? Ammonia. To give ammonia. Before we proceed, what is this? How many atom of nitrogen do we have at our left hand side? We have 2, so we have 1. So let's make nitrogen to be 2 here, and let's make hydrogen to be, so our reaction is balanced. 2 nitrogen, 2 nitrogen, 6 hydrogen, 6 hydrogen. The reaction is balanced. This is our reactant, and these are what? Product. These are our product. This is an example of a system at equilibrium. This is an example of a system at what? At equilibrium. Now, we are going to proceed to look at how change in temperature, how change in pressure, and how change in concentration can affect the system at equilibrium. And when it does, what actually happens? Where does the equilibrium constant shift to? Does it shift to the left or shift to the right? That is what we are going to look at right now. Does it shift to the left or shift to the right? So let's remember our Latecheller's principle. It's a Frenchman. He defined equilibrium as in such a way that when the backward reaction is equal to forward reaction, when the backward reaction is equal to forward reaction, it was exploded. So change the temperature. Change in what? Temperature. Change temperature. So let's take an example of a reaction. Take an example of a reaction. Of course, when it comes to change temperature, let's take a look at one. Now, we are going to consider a reaction at equilibrium whereby there is a change in temperature. But before that, we are going to look at 2 major things: exothermic and endothermic. Exothermic reaction are reaction that proceed forward reaction when it is released. Endothermic reaction takes in, the more they takes in energy, the more they takes in heat, reaction proceeds forward. So there are 2 things. There are some reaction, they give out heat. They give out heat and they proceed forward. There are some, they absorb heat and they proceed forward. Any reaction they absorb heat is an what? It's an endothermic reaction. Change the temperature. So let's look at this together. Let's look at a compound like calcium triacylcarbonate 4. Calcium triacylcarbonate 4. When you decompose calcium triacylcarbonate 4, it's going to give us calcium oxide. It's going to give us calcium oxide, carbon 4 oxide. Calcium oxide and what? Carbon 4 oxide. Liquid, solid. Now, most reaction it will be written if change in enthalpy is positive or negative. But we are talking about temperature at this time. We are talking about temperature. Now, change in enthalpy in this reaction is what? Positive. Change in enthalpy is equal to what? Positive. Now, before we proceed, you have 5 minutes to think and brainstorm. What do you think will happen in a reaction like this? What is the effect of temperature? That is, when the temperature is increased and when the temperature is reduced, what happens? You have 5 minutes to brainstorm before we continue our lecture. You have to brainstorm. Brainstorm. Now, if a reaction, so I would like to write a question. If a reaction, this is an endothermic reaction. This is what we call endothermic reaction. Endothermic reaction. It means the more heat is absorbed, reaction proceeds forward. It means the more heat is absorbed, reaction proceeds forward. So now, what is the effect? The question says, what is the effect of increment what is the effect in the above reaction when the what temperature is what? When the temperature is what? Increase. When the temperature is increased, what is the effect? Because this is an endothermic reaction. You know, because this is an endothermic reaction, when the temperature is increased, it favors the product side. In an endothermic reaction, when the temperature is increased, it favors what? Product reaction. So therefore, increase the production of what? It increase the production of what? Calcium oxide and water. So when the temperature is increased, it increase the what? Production of calcium oxide and water. In an endothermic reaction, an endothermic reaction is a reaction that proceeds forward when the temperature is increased because they absorb heat. That is what makes the reaction to proceed. Why exothermic reaction, they give out heat. The more they give out heat, the more reaction proceed forward, the more product are formed. So in this reaction, the question say, what is the effect in the above reaction when the temperature is increased? When the temperature is increased, look at the change in enthalpy. Change in enthalpy is what? Positive. It means it means for forward reaction, heat is absorbed. So when you are now you are adding more heat, what happens? You are increasing the temperature. When the temperature of the system is increased, what happens? Don't forget, we are in a closed system. Closed system. We are in a closed system. Now, it produces effects. Effects are one, more of calcium oxide is what? Produced. Two, more of what? Water is what? Produced. Is produced. Three, equilibrium constant shift to what? To what? The what? The right. Equilibrium constant shift to the right. Equilibrium constant shift to what? The right. So in endothermic reaction, it acts as product. So in an endothermic reaction, it acts as what? As product. In an endothermic reaction, it acts as what? Product. In an endothermic reaction, it acts as product. It acts as product. So in an endothermic reaction, it acts as reactant. It acts as what? Reactant. Where in an endothermic reaction, it acts as, in an exothermic reaction, it acts as product. So let's proceed to pressure. Increase the pressure, shift equilibrium to fewer gas molecule. Increase in pressure, shift the pressure to what? To fewer gas molecule. Effect of what? Pressure on a system at what? Equilibrium. Effect of pressure on a system at equilibrium. So let's look at this system now. Let's look at when nitrogen reacts with hydrogen to give ammonia. When nitrogen reacts with hydrogen to give ammonia, what now you'll be asked, what is the effect? Now, before that, all the product, these are our reactants, these are our reactants, these are our reactants, these are our products. They are all in gaseous state. Good. For pressure to have effect on reaction, they should be in gaseous state. Okay. Good. Now, before we proceed, let's balance our reaction. Before we proceed, let's balance our reaction. Nitrogen, hydrogen. Good, good. Nitrogen reacts with hydrogen, it produces ammonia. This is ammonia. This is ammonia. This is ammonia. Ammonia. So now before we continue, let's balance our reaction. Nitrogen, 1 here. Nitrogen, we have 2 nitrogen here. So let's make this got to be 2. Since we have 2 nitrogen at our left hand side. 2. Now let's proceed. Hydrogen 2. Hydrogen 6. So let's add 3 here. So let's start again. Nitrogen 2. Nitrogen 2 here. Nitrogen 2. Nitrogen is balanced. Hydrogen is 6. Hydrogen is 6. Reaction is what? Balance. Balance reaction. So we must balance our reaction. We must balance our reaction before we proceed. Now, the question is, what is the effect when there is an increment in pressure, when you increase the pressure of the system, what happens? The question will now be questioned. What is the what? Effect of, what is the effect if the pressure of the system is what? Increased. So what is the effect if the pressure of the system is increased? What is the effect if the pressure of this system is increased? Now, before we know what's going to happen, look at the question. What is the effect if the pressure of the system is increased in this reaction? In this reaction, what is the effect? Before we know the effect, we must write number of mole for both reactant and product. We must write number of mole for what? Both reactant and what? And product. Now, let's write 1 plus 3, 4. 4 moles, 2 mole. Now, when the pressure is increased, it favors side with lesser pressure. In a reversible reaction, when the pressure is increased, it favors side with lesser number of mole. So equilibrium system will shift to what? To our right side, thereby producing more of ammonia. When the reaction is at equilibrium and the pressure is increased, and the pressure of the system is increased, it favors side with less number of mole. So in this reaction, when nitrogen reacts with hydrogen, more of ammonia will be produced. When nitrogen reacts with hydrogen, more of ammonia will be produced. So in this question, what is the effect of if the pressure of the system is increased? In a reversible reaction, if pressure can act on the system, if all the negation state, what happens is when you increase the pressure of the system, it favors side with less number of mole. Now, our product side has less number of mole, therefore ammonia will be produced. Ammonia will be produced. In an equilibrium, if that, I don't want to waste, I don't want to write, you know. So basically, I will dictate it. It is not by explanation, not by notes. You must understand this concept. It's very essential. In a reaction at equilibrium, when the pressure is increased, it favors side with less number of mole, thereby producing more of ammonia. More of ammonia is being produced. More of ammonia is being produced in a reaction at equilibrium. So, for more of ammonia will be formed. This is the principle they use in production of many materials in a chemical industry. You know, limestone production, they employ most of those principles. So this is for what? For pressure. We are going to look at another factor that affects the system at equilibrium. So now we have been able to establish that increment in pressure, when the pressure is increased, it favors side with fewer number of mole. In this case, we have only 2 mole of what? Of ammonia, and we have 4 mole here for both nitrogen and hydrogen. So it favors side with what? The lesser number of mole, which favors the product of what? Ammonia. So ammonia is produced. Ammonia is what? Ammonia is what? Is what? Produced. Ammonia is what? Is produced. Ammonia is produced. So we are going to proceed. Now, another question. Another question. Decrease. What is the effect of decrease in the pressure of the system? Of the what? Now, according to Letourneau's principle, when a system is at equilibrium and you decrease the pressure, it favors side with higher number of mole. When a system is at equilibrium and you decrease the pressure of the system, it favors the side with what? Lesser number of mole. But when the system is at equilibrium and you increase the pressure, it favors side with what? Lower number of mole. Decrease, lower, lower, decrease. So in this case now, I say question. The question says, what is the effect of decrease in pressure of the system? If you decrease the temperature of the system, what will happen? That's what we are saying. In this system, when nitrogen reacts with hydrogen, it produces ammonia. Good. Now, when you what? You say, what is the effect of decrease? When the temperature is, when the pressure of the system is decreased, when the pressure of this system is decreased, what happens? When the pressure of this system is decreased, what happens? It favors side what? Higher number of mole. Therefore, nitrogen and hydrogen will be produced. When the system is decreased, when the pressure in this system is decreased, when there's a decrease in pressure in this system, what happens? It favors side what? Higher number of mole. So nitrogen will be produced, hydrogen will be produced. Therefore, it favors the production of both nitrogen and hydrogen. So when the system is at equilibrium and the temperature is increased and the pressure is increased, it favors side with lower number of mole. But when the pressure is what? Reduced, it favors side what? Higher number of mole. Simple. We are talking about other effect of pressure. Don't forget we have three major what? Constraint. Three major things that act as external constraint: change the temperature, change the pressure, and change the concentration. Please let's also remember to use the word change, because that is what matters most. Pressure can be there, but is there effect? No. So now, when a system is at equilibrium, and the temperature is increased, it favors side with lower number of mole. Ammonia will be produced. Ammonia will be what? Produced. I want us to look at more examples. We are going to look at more examples right now. Let's look at more examples. We're going to look at more examples. So let's look at another effect, catalyst. We have looked at three major things that affect a system at equilibrium, which act as external constraints. So catalysts do not change. Catalysts do not what? Shift the what? The equilibrium constant. Catalysts do not shift the equilibrium constant. Catalysts do not shift the equilibrium constant. It only speeds up attainment of equilibrium. It only what? Speed up the what? Attainment of what? Equilibrium. It only speeds up what? the attainment of what? Of equilibrium. So we are going to look at Haber process. Industrial example. Let's look at Haber process. Let's look at Haber process. We are going to look at Haber process, industrial example. It is an what? Industrial example. That's what we said earlier. Most of those reactions takes place in industry. So if you want to produce a particular item, so when nitrogen reacts with hydrogen, so now when nitrogen reacts with hydrogen to produce ammonia, let's balance our reaction. Okay, 3 here, 2 here. Our reaction is balanced. We should not forget we have 4 mole here, we have 2 mole here, we have 4 mole and 2 mole. Now let's proceed. Condition: high pressure. So this is an example of what? Of an endothermic reaction. So now let's look at this together. Condition: high pressure. What is the condition for this to be? Say, what is the condition? High pressure, 200 atm. Condition is what? One, high pressure. That is one of the condition. Moderate temperature. High pressure at what? 200 atm. 200 A atmospheric pressure. Then moderate temperature, 45. Condition for this reaction to take place: moderate temperature. (45 degrees centigrade). Now we have a catalyst. We have a catalyst which is iron. That's our catalyst. So we are going to look at equilibrium in ionic reaction. Equilibrium in what? Ionic reaction. We are going to look at equilibrium in what? Ionic reaction. Equilibrium in what? Ionic. Equilibrium in ionic reaction. So let's look at ethanoic acid. Ethanoic acid. This is an ethanoic acid. When ethanoic acid, there's H in front of it. When undergoes decomposition, that is when ethanoic acid undergoes decomposition. So it explains the acidic strength. This reaction, it shows the acidic strength. You can see acidic strength. Acidic strength, it demonstrates acidic strength of the acid. It demonstrates acidic strength. Then apart from that, weak, so it also demonstrates weak versus strong electrolyte. It demonstrates weak versus what? Strong electrolyte. So we are going to look at some terms. We are going to look at some terms now. So the term we are going to look at are equilibrium position, relative among reaction, homologous equilibrium. Homologous equilibrium is equilibrium in the same phase. Like this is an homologous equilibrium. They are all in the gaseous phase. Gas, ammonia is a gas, nitrogen is a gas, hydrogen is a gas. That is homologous equilibrium. All the reactant and product and what in one phase. That is homologous equilibrium. So apart from that, we are still going to look at heterogeneous equilibrium, different phase. Well, heterogeneous equilibrium when all the both product, a product can be what? Aqueous or gas, and we can have solid. That's what we call homologous equilibrium, heterogeneous equilibrium. So we can say example of homologous equilibrium are this Haber process. Is an example of what? Homologous equilibrium. So let's look at importance of a chemical reaction. Chemical reaction produce ammonia, sulfuric. Environmental chemistry, buffer solution, and pH control. Those are the importance, of a chemical equilibrium. Buffer solution, environmental chemistry. Environmental chemistry. So now, before we proceed, I want us to look at this together. What is the effect of change in temperature? No, what is the effect of change of concentration in this compound, in this reaction, when calcium tricarbonate 4 react to give calcium oxide plus carbon 4 oxide? What is the effect? What is the effect? Our reaction is balanced. What is the effect of change in what? Concentration. So few minutes, take few minutes of your time, and what is the effect of change in concentration? Okay, let me put it this way. When carbon 4 oxide is removed, what is the effect of when carbon 4 oxide is removed from what? From the product side. What is the effect? So let me see your answer. Let me see your answer. Drop your answer in the comment section. Drop your answer in the comment section. Don't forget, we say what is the effect in this reaction when carbon 4 oxide is removed. What is the effect in the reaction when carbon 4 oxide is removed? What is if when carbon 4 there is removed? So let's look at formation of sulfuric acid, which is sulfur what? Which is sulfur 6 oxide, the sulfuric acid. So SO3, SO2, SO2. This is sulfur 4 oxide. It's acidic. It's an oxide of nonmetal. Oxide of nonmetal are always acidic, while oxide of metal are basic. And we also have amphoteric oxide like zinc oxide. So now let's look at formation of sulfuric acid when this reacts with what? Oxygen. When this reacts with oxygen, it gives what? SO3. It gives SO3, which is, this is sulfur what? 6. Sulfur 6 plus heat. Plus heat. So in this reaction, this is formation of sulfuric oxide. Now, the question comes, let's balance our reaction. What is the effect of production of sulfur 6 oxide? What is the effect? How can you produce sulfur 6 oxide? How can you produce this? There are many ways. If the question is not limited to temperature, we can expand it. So we can produce sulfur 6 oxide when sulfur 6 oxide is removed. The more sulfur 6 oxide is removed, the more it is being produced. When this reaction changes enthalpy, so this is an endothermic reaction. This is an endothermic reaction. So as the reaction proceeds forward, more sulfur 6 oxide is produced. So if that's the case, when you increase the temperature, what happens? More of sulfur 6 oxide will be produced. When you increase the temperature, more of sulfur 6 oxide will be produced. Then when you increase the concentration of sulfur 4 oxide, more of sulfur 6 oxide will be produced. There are many ways. It depends on the one you want. When you increase the concentration of oxygen, sulfur 6 oxide will be produced too. When you increase the concentration of oxygen, sulfur 6 oxide will be produced too. Okay. I can see in the comment section someone is asking that why is it called sulfur 6 oxide and not sulfur 3 oxide or sulfur 2 oxide? Okay, that is a different topic, but for the sake of this question, I would like to answer the question. Although that is a different topic entirely, which falls under inorganic nomenclature. Nomenclature means naming of inorganic compound. We have organic nomenclature and inorganic nomenclature. So for the sake of that question, let me just bring it out. Is this a charge? This compound is not charged. It's not a radical. It's not like SO3 minus 2. It's not a charged compound. So any compound that is not charged is equal to 0. It's equal to 0. So let's proceed. Make S subject to the formula. So we have S plus, what is the oxygen number of oxygen? Minus 2 times 3 is equal to what? 0. Is equal to what? 0. So we have S minus 6 is equal to 0. S is equal to 6. That is why it calls for what? 6 oxide. We are going to treat this one separately as a topic. We'll treat it separately as a topic. We'll treat it separately. So you can be asked, when the what is the effect in this reaction when the concentration of sulfur 4 oxide is reduced? Equilibrium will shift to the left hand side. If the concentration of sulfur 4 oxide is reduced, equilibrium will shift toward our left hand side, thereby producing more of sulfur what? 4 oxide. So I'm answering this question based on what concentration. When one asks you, what is the effect when you reduce concentration of sulfur 4 oxide? When you add oxygen to this system, what happens? More of sulfur what? Because it's going to combine with sulfur 4 oxide to produce more of sulfur 6 oxide. It will definitely combine with sulfur 4 oxide to produce sulfur 6 oxide. In a closed system, we are in a closed system. We should not forget closed system, so that energy is conserved and matter is conserved. That's our aim. Energy is conserved, matter is conserved in a closed system. Energy and matter are conserved. So forward reaction is in this reaction. Forward reaction is produced when heat is increased. The more heat is increased, forward reaction is favored, thereby increasing equilibrium constant. Equilibrium constant shift to what? To the right hand side. Equilibrium constant shift to what? To the right hand side. So let's look at calcium trihydrocarbon 4 plus heat. Calcium oxide plus what? Okay. So now, calcium trihydrocarbon 4, if you apply it, it's going to decompose to produce what? Calcium oxide, carbon 4 oxide. That's what we call thermal dissociation of calcium carbonate or calcium trihydrocarbon 4. Calcium trihydrocarbon 4. So now, what happened? What is the effect of temperature? The question says, what is the effect of temperature in this compound? What is the effect of temperature? What is the effect of temperature? So it increase in temperature, add heat. If you increase the temperature of this system, it add heat to the reactor side. So if you increase the temperature, it will be at the reactant side. What will happen? More of this will decompose. So equilibrium will shift to what? To the right hand side. Effect of increment in heat. When you add heat to this system, number one, equilibrium shift to what? Equilibrium what? Shift to what? To what? Right hand side. Product, which result to what? Product formation. which result to what? Product formation. It results to product formation. We are talking about effect of temperature in this reaction. When change in enthalpy is what? Change in enthalpy is what? It is positive. Change in enthalpy is what? Positive. So the more you apply it, the more calcium oxide is produced and carbon dioxide is produced. The more you apply it. Okay? Now let's proceed. What is the effect of decrease in temperature? What is the effect of decrease in temperature in this system? When you decrease the temperature, equilibrium shift to the what? To your left hand side. When you decrease the temperature, equilibrium will shift to what? To your left hand side. So in a process, in this reaction, calcium carbon plus calcium oxide and carbon dioxide, when you decrease the temperature, equilibrium shift to what? To your left hand side, because this reaction is an endothermic reaction. This reaction is an endothermic reaction. So more of calcium and carbon what will be produced. More of it what will be produced. So let's look at when ammonium chloride ammonium chloride is a solid. Ammonium chloride is a solid. When you apply it, it's a solid, apply it. It's a solid. When you apply it, it produces what? Ammonia plus ACl. It produces what? Ammonia plus what? ACl. This is the reaction. When ammonium chloride is heated, when you apply it, it produces what? Ammonia and HCl. And the ammonia here is gas. The ammonia is what? Gas. Gas. So now, let's proceed. The question comes, what is the effect in this reaction? What is the effect when temperature is increased? When the temperature is increased, what happens? When the temperature is increased, it produces more of what? Ammonia. It produces more of what? Ammonia and HCl. Don't forget, what activates this reaction is when heat is added to this reaction. So when you continue to add more heat, more production of what? Ammonia and what? HCl. That one is very clear. So now, when there is reduction, what is the effect of decrease in temperature? More of ammonia will be produced. That is, HCl will combine with ammonia to produce what? Ammonium. Hydrogen chloride will combine with ammonia to produce what? Ammonium chloride. To produce ammonium chloride. That is the effect. So, in summary, exothermic reaction. So now, there is a point we want to bring out here. We have two types of reaction in respect to temperature: endothermic reaction and exothermic reaction. So when effect of temperature, we are going to look at effect of what? Of temperature. If you increase the temperature, in an exothermic reaction, if you increase the temperature, equilibrium constant shift to the left hand side, thereby favoring the production of what? Products are produced. But in an endothermic reaction, if you increase the temperature, it favor what? Equilibrium, it shift to what? To the right hand side, therefore favoring the production or formation of what? Product. Formation of product. One product is what? Will be formed. So these are some reactions that we should put in our fingertips. They are very helpful. So far, we have been able to learn that there are three factors that act as an external constraint for a reaction at equilibrium. And we have been able to state that temperature, concentration, and pressure. Catalyst does not have any effect on the reaction at equilibrium. Catalyst does not have any effect on the reaction at what? At equilibrium. Catalyst does not have any effect on the reaction at what? At equilibrium. So now, before we proceed, we are going to give a reaction. You should be able to tell what happened. Consider this reaction: calcium hydrogen trioxocarbonate 4, which produces calcium trioxocarbonate 4, water, and carbon dioxide. So in this reaction, what is the effect of change in temperature, change in pressure, and change in concentration in all the species? That is calcium hydrogen trioxocarbonate 4, calcium trioxocarbonate 4, water, and carbon dioxide, excluding catalyst, because catalyst does not have any effect. So I would like to see your answer in the comment section, and meet again in our next class. Thank you so much.